Now let's compute some infinite limits. I want to compute limit as x approaches pi from the right of cosecant x. If I was you, I would rewrite this problem as limit as x approaches pi from the right. Cosecant x is the same thing as 1 over sine x. Okay. But before we move on, let me show you what is the graph of cosecant x look like. Especially when we want to look at the point approaches pi from the right. So here the secant graph, pi from the right there, the purple dot, that's pi. If you approaches pi from the right, it looks like to me the function go to negative infinity, right? So let's take a look algebraically. Now, if I plug in pi approaches from the right into the function, 1 over sine of pi from the right. Let's see what it looks like graphically. So that's roughly a sine graph. So at pi, sine of pi is 0, right? But we want to approach this pi from the right. So I want to approach this pi from the right. Just go closer and closer to pi from the right. What does it look like? I'm going to smaller to the well, not a smaller in distance. I'm approaching to 0 from beneath, right? So you get close to 0 from beneath, so but not quite 0, right? So it's some negative 0.000 or something, right? So we call that 0 from the left, right? So I'm approaching, so approaching to 0 from the left. So meaning meaning negative 0.01. If you want to get closer and close to 0, mean negative 0.001. Closer to 0 still, negative 0.00000. Oops. Come on. 0, 0, etc. 1, right? Right. So some number some negative number that very close to 0. So we call that 0 from the left. So this is equal to 1 over 0 from the left. Well, what's 1 divided by 0 from the left? Well, let's take a look. If I take 1 divided by negative 0.1, you got negative 10, right? If I take 1 divided by negative 0.01, I got negative 100. If I take 1 divided by negative 0.0001, I got negative 1,000, etc. So the negative that if you divide the number if you divide a negative number that closes to 0, you got a bigger, well, you got a smaller negative number, right? I shouldn't say it's bigger because apparently negative 100 is smaller than negative 10, right? So eventually, if I divide 1 by negative 0.000000 all the way to 1, I got a really large number. I'm going to call it negative infinity. Well, a really small number. I could call it negative infinity, right? So equal negative infinity. Right. Delete these. Limit as x approaches 0 from the left of 2 minus 1 over x. Let's take a look at the graph 2 minus 1 over x. Let me mute the first two. So it's right there. I want to evaluate 0 from the left, right? If I approach 0 from the left, it looks like I'm going to positive infinity. So the first thing I do when I evaluate limit, I'm going to plug it in. Limit as x approaches 0 from the left of 2 plus 1 over, oops, I meant minus 0 from the left. Limit difference is the difference of two limits. So limit at x approaches 0 from the left of 2 minus limit as x approaches 0 from the left of 1 over 0 from the left. Well, this one right here is just 2, right? Because 2 is not depend on x. Limit of a constant is equal to the constant. So it's just equal to 2 minus 1 divided by 0 from the left, that's negative infinity. So 2 plus infinity, well, 2 plus infinity is still infinity. Now let's take a look at the problem where we want to find the vertical asymptote of the function, right? Asymptote of the function is where the points that make the function undefined in calculus meaning is that the limit does not exist around that point. Right? So it's sufficient to find that the point where the function is undefined here, right? Is undefined where the denominator is equal to 0. Is undefined where x squared plus x minus 2 equals 0. You can factor that. So x, I got plus 2 minus 1. Right? So either x equal -2 or x equal 1. Those will be your two vertical asymptote. Should put plural here, vertical asymptotes. All right, thank you for watching. Hopefully see you next time.